Okay, good morning all. I'm audible. Reply in chat box. Okay. So, Miski, today, Miski mainly focus on the DBMS gate lecture. Okay. Hmm. So today's lecture means ki subject name is hot databases and topic covered in today's lecture is a ER model and relational model. This is session number 1 of the GATE lecture and date is 4 September 2021 and 9 to 11 a.m. lecture. And in GATE exam point of view, so this one subject is database subject is required, right? So in GATE syllabus, so first means we discuss means ki some GATE syllabus of the DBMS and then actual start actual means ki lecture. So in GATE syllabus, databases is the one part, is the one section. So in this section, means ki, this 5 to 6 points in a database section. So first one is a ER model. Okay, so some questions in GATE exam, 1 mark or 2 mark based on the ER model. Then a relational model is one of the point. In a relational model, ki some GATE means ki questions in GATE paper. Then a relational algebra is a one point inside the relational model and tuple calculus. So most of the paper ki one question on the ER model, one question on the relational model, or sometime in relational algebra, or sometime in tuple calculus. So 1 mark on ER model, 1 or 2 marks on relational model. Then one questions on SQL integrity constraints and normal forms. Here also one question in GATE exam. Then one question on the file organization and indexing bit and B plus tree, and one question on the transactions and control. So means mainly 8 to 10 marks. It means out of 100, 8 to 10 marks in a database, and it is very easy because each and every point means cover means at least one question. Because some paper 8 mark question, some papers for example 7, some paper 9. So some little bit 1 or 1 2 marks either means change. So means approximate means 8 mark questions on the means ki database in GATE exam. And means ki today's lecture means ki focus on the points ER model and some questions of the ER model as a GATE point of view, then relational model. So these points means ki cover in today's GATE lecture. So listen carefully. Means in GATE exam, we start with the means ki today's GATE lecture. Hmm. So the subject is a databases. Means ki 8 marks, approximate 8 marks in GATE exam for the database subject, and topic is a ER model and relational model. So my means ki one important thing ki here means ki understand each and every means ki basic points or basic concepts of the means ki every point to easily solve any type of the question in GATE exam. Okay, so mainly focus on the basic point first and then solve means ki questions of the GATE means as a multiple choice questions. So it is a very easy means ki, database subject in a GATE exam point of view, and easily get means ki 6 to 8 marks in databases. And I think all of you know for the database subject means 8 marks and passing marks of the means approximate 25 to 30 marks for the open, 22 to 23 for the means OBC, and suppose 80 or 19 marks for the SC ST students. So means out of this here means 8 marks cover in database subject, and it is a means in curriculum in T computer or TIT this subject is available. So usually solve these questions and get means full marks in databases. So crack करायचे असेल get, so here means you get 8 marks here, so easily crack GATE exam. So start with the means actual concepts of the database first, and then actual means questions means multiple choice question in GATE exam discuss. Okay. So point is a ER model and a relational algebra. These 2 points discuss in today's GATE lecture. Okay. So I think all of you know entity relationship diagram because some concepts is covered in suppose curriculum. So entity relationship diagram. So what is entity? Ki suppose in any suppose database project or any suppose system or any project, suppose consider as a banking system. So in banking system, suppose customer is available in banking system, account is available, and then suppose branch. So account is an entity, then customer is an entity. Okay, same in suppose in college management system, suppose okay, suppose student is a one means ki entity, then staff is a one entity, then account is a one entity in student means college, then placement, then means the number of entities available. So entity is a collection of the attribute. Is the basic concept. Okay, suppose consider as a student as an entity. So entity is a collection of the attribute normally. Okay, so attribute is roll number, name, address, and all. So here an entity relationship model describes the structure of a database with the help of a diagram, which is known as an entity relationship diagram or ER diagram. Suppose here means draw any system diagram. Example, you suppose college management system. So here draw diagram of the means college management system. So here cover some entity. Example, college is a one entity, then student is a one entity, faculty is a one entity, department is a one entity. So entity relationship model describes the structure of a database with the help of a diagram which is known as entity relationship diagram. Simple. Then it is high level data model. It is a one data model because in database system several data model is available. Relational model, then ER model, hierarchical model, network model. So ER is a one type of the model. Okay. So it is a high level data model. This model is used to define the data elements and relationship for the specific system. Simple. It develops a conceptual design for the database. It also develop a very simple and easy to design view of the data. Okay, means normally in database system view of the data, physical view, logical view, and view of the data is available. Suppose means design any system. So here means first task here design diagram of the means particular system in database. Okay, so this diagram is called as normally entity relationship diagram. So ER model is considered a good option for the designing the database. So design any database. So mainly focus on the first point is the ER model. Okay. And GATE exam as a first point in GATE exam is the ER model. Okay. It is a very easy model. So then some components of the ER diagram. So ER model is divided into three parts. First one is the entity, second one is the attribute, and third one is the relationship. So entity means here entity also two types. One is a weak entity and another is a strong entity. What is strong entity? In strong entity, means primary key is available, then this entity is called as simple strong entity. Okay. And weak entity means here primary key is not available, so this entity is called as weak entity. Simple. The entity basically two types: the strong entity and weak entity. Okay. Then attribute. So attribute means what is entity? Entity is a collection of the attribute, right? So in attribute, so here key attribute, composite attribute, then multi-value attribute, and derived attribute. So these are the some types of the attributes. Okay, these are the some types of the attributes. And next one is the relationships. Okay, in ER model basically focus on this point: entity, then attribute, then relationship. So one to one entity, one to many entity, sorry, one to one relationship, one to many relationship, many to one relationship, and many to many relationship. These are the some abstract level of the ER model. So in ER focus on entity, attribute, and relationship. So in detail see the what is type means explain means entity types, then attributes, and then relationship. Okay, so start with the first entity. So an entity may be an object. Okay, it is a means it is an object with a physical existence. And some example of the entities are person. Person is a one entity. Car. Car is a one entity. Then house is a one entity. Employee is a one entity. Student is a one entity. So here one simple example of the student. Okay. So student is a one entity. So it is represented in rectangle. You suppose in ER diagram draw any entity. So it is in rectangle. So student is a one entity. Student is a one entity. Okay, this is one example of the entity. Second example is employee. So employee is a one entity, then works for department. So department is a one entity. So in this student entity, employee entity, and department entity, so it is denoted in rectangle. So this entity is denoted in rectangle. And suppose some attributes of this employee is a employee ID, employee name, employee department, employee salary, employee address. These are the attributes of the employee entity. And here suppose department. So department entity, suppose some attribute department ID, department name. These are some attributes of the department entity. The student entity, some attributes: roll number, name, address, email ID, mobile number. So these are the some attributes of the student entities. I think this concept is clear. What is entity? In entity relationship diagram, entity is the main messy part. So entity, I think all of you know this entity. Okay, simple. Then entity set. Okay, so entity set is an object of the entity type and set of all entities is called as entity set. Example, E1 is an entity having entity types. Student and set of all student is called as entity set. And there is one example of the entity set. Okay, so this is simple. A student is a one relation. A student is a one table. Simple. So here a roll number, then student name, then age and mobile number. These are some attributes of the student entity, right? And then here, one and row suppose 18, and he's a one record. Normally in relational model it is called as, a relational algebra is called as a tuple. So one Andrew 18 is a one tuple. Okay, so in this relation, four tuples. Okay, but actually here identify the entity set. Okay, so E1 is a one tuple, E3 is a one tuple, E2 is a one tuple. So simple. Here E1, E2, E3 is a E1, E2, E3 is a entity set. Okay, simple. This is the entity set of the entity set. Simple. And then attribute. So entities are represented by a means of their properties called as attribute, and it is denoted in this ellipse or oval. So means entities are represented by means of their properties called as attributes, and all attributes have values. For example, a student entity may have a name, class and age as an attribute. Okay, so suppose student is a one entity, so name is an attribute, class is an attribute and age as an attribute. In ER diagram, attribute is represented by an oval. Simple. Okay, so in attribute also several types. So first type of the attribute is a simple attribute or a key attribute. Simple attribute or key attribute. So simple attributes means कि here कि atomic values for specific attribute, and this attribute is not divided into subparts. One simple example of the simple attribute is the roll number. In roll number normally in 1, 2, 3, 4, 5 in format. Oh, in number. You normally असं नसते की suppose 1.1 is a roll number, 1.2 is a roll number, 1.3 is a roll number. So roll number is a key attribute. Simple. कि roll number is a key attribute, and here in roll number, so unique value 1, 2, 3, 4. It is not divided into subpart. Means roll number 1, 1.1, 1.2, 1. This is a subpart of this roll number 1. But actually number in roll number in only in number 1, 2, 3, 4, 5, 6. So roll number is a simple attribute. And normally in suppose student is a one table, student is a one relation. So in this relation is a student means roll number is a key attribute. Okay. So atomic values which cannot be divided further means ki simple attribute or key attribute. So example of the simple attribute is what? Roll number. So roll number will be unique for each student. In ER diagram, key attribute is represented by an oval with underlines. So here roll number in suppose ER diagram, this is in oval or in ellipse. So here simple roll number underscore number. So roll number is what? Is a key attribute. Okay, or suppose is a primary key or key attribute, so it is represented in underline. So roll number is a simple attribute or key attribute, so it is underline means here the primary key or key attribute of this particular relation or particular. Suppose student is a one relation, so roll number is a key attribute, so underline. Simple. Composite attributes. So composite attribute means ki particular attributes divided into subpart. Okay, so simple here. An attribute composed of many other attribute is called as composite attribute. So example, address attribute. Address attribute of the student entity type consists of the street, city, state, and country. So in ER diagram, composite attribute is represented by an oval comprising of oval. So here address is divided into subparts. So street, city, state, and country. So here address is divided into street or city or state or country. So this is an example of the composite attribute. Second example of the composite attribute, name. Suppose student name or person name or customer name is divided into first name, middle name and last name. So name is a composite attribute. Means ki particular attribute divided into subpart. So this attribute is called as simple composite attribute. Okay. Multi-value attribute, an attribute consisting more than one value for a given entity. Attribute have more than one value, so this attribute is called as multi-value attribute. For example, phone number or mobile number can be more than one for a given student. So mobile number is a means ki multi-value attribute. In ER diagram, multi-value attribute is represented by a double hole or double means ki double oval. This phone number. So phone number is a multi-value attribute. Simple. Okay. Then next one is a derived attribute. So derived attribute means ki divided into some other means using one attribute means ki derive another attribute. So this attribute is called a simple derived attribute. So here simple example, an attribute which can be derived from other attribute of the entity type is known as derived attribute. So example H can be derived from DOB. Suppose consider ki one student is a one entity and date of birth is a one attribute. Using this date of birth attribute easily means ki find out the age of the particular student. So age is a derived attribute of the date of birth. So here age can be derived from the date of birth. So in ER diagram, derived attribute is represented by a dashed oval or dashed ellipse. Okay. So here simple example, here age. Age is a derived attribute and is derived from the means ki actually date of birth. A simple. Then example, here some example. In this example, we have discussed a student is a what is student? Student is an entity. Then roll number. What is roll number? Roll number is a attribute. Name is a attribute. DOB is a attribute. Phone number is a attribute. But this attribute is what? Multi-value attribute. And here age. Age is a derived attribute and this derived from this DOB. Date of birth पासून हा derive झाला. So here age is a derived attribute and it's a dotted oval or dotted ellipse. Okay. Then here student means address. Address is a attribute and address is a composite attribute because this attribute divided into subparts. So here simple country, then state, then city, then street. So address is a composite attribute. Okay. Then relationships are type and relationship set. Relationship type and relationship set. So simple here, a relationship type depends in association between two entities or entity types. So it's simple, two or more entities, suppose example two entities, and here some linking of these two entities. So here use relationships. Okay. So here simple, for example, enroll, this enroll in is a relationship type and that exists between entity type student and course. So here simple, student is an entity and here course is an entity. Student is a one entity and course is a one entity. Okay, and here means we use relationship as a enroll in. So this simple relationship and it is denoted in diamond. This is a diamond, this is a rectangle. So relationship is denoted in ER diagram in diamond, and suppose entity is represented in a rectangle, this rectangle. So degree of the relationship set. A relationship type represent the association between entity types. Okay. So it's simple, inner relationship where there is only one entity, when there is only one entity set participating in a relation, the relationship is called as unary relationship. Okay, so in unary relationship means ki only one entity and here only one relationship. So this relationship is called as simple unary relationship. So a simple example of the unary relationship. So a person is a one entity and married to is a one relationships. Person married to person म्हणजे पर्सन हा मॅरेज कोणाशी करतो पर्सनशीच करतो राईट सिम्पल एक्झाम्पल सो पर्सन इज अ वन एंटिटी मॅरिड टू इज अ वन एंटिटी सो पर्सन मॅरिड टू पर्सन दिस सिम्पल युनरी रिलेशनशिप सिम्पल ओके second one is a binary relationship in binary relationship two entities and one relationship two entity and one relationship so this relationship is called as binary relationship so a simple example when there are two entities set participating in a relation the relationship is called as binary relationship for example student is enrolled in a course what is student is a one entity what is course is a one entity and enroll is a relationship among these two entities student and course so here simple this relationship is called as binary because 1 and 2 is a binary relationship of the part. This is simple ER diagram. So in this ER diagram, binary relationship student and course. Okay. Ternary relationship means when there are three entities a set participating in a relation when there are three entities said participating in a relation, the relationship is called as Turner relationship. So here simple, for example, doctor prescribes medicine and the doctor prescribes a patient. So here entity 1, entity 2, then here entity 3. So very simple, ternary relationship means three entities and one relationship. So this simple ternary relationship. So here doctor prescribes patient, then patient means here doctor prescribes patients, then doctor prescribes medicines. So here this simple example of the ternary relationship. Okay, means here three entities and one relationship. Simple. Okay. Then quaternary relationship, when there are four entities, when there are four entities said participating in a relation, the relationship is called as uh, quaternary relationship. Okay, so this relationship is called as a quaternary relationship. By mistake here binary. So here quaternary relationship is a quaternary relationship. And here simple example. So in this example, professor is a one entity, course is a one entity, student is a one entity, and slide is a one entity. These four entities connected to these teachers. So teacher is what? Teacher is a relationship. Okay. So here professor, slide, student, and course. This is simple example of the quaternary relationship. Okay. Miss here Miss cover all basic points of the ER diagram. So easily solve any type of the question in GATE exam. Okay, because here means GATE exam important thing is what basic knowledge is very important, because in GATE exam number of means subjects available. So every subject means only 5 to 6 points. Not all points of the every subject. So important thing first means clear each and every point. Means basic point of the every subject, then easily crack GATE exam. Okay, because means my score means first attempt is a 92.94 percentile score in my GATE exam in first attempt. Okay, म्हणजे पहिल्यांदाच मी क्वालिफाय केली गेट पहिल्या अटेम्प्ट मध्ये, राईट. सो माय स्कोर इज 92.94 पर्सेंटाईल. सो मीन माय फर्स्ट फोकस ऑन द मीन मी काय केलं होतं की फोकस ऑन द इच अँड एव्हरी बेसिक पॉईंट ऑफ द सब्जेक्ट्स, मीन्स ऑल सब्जेक्ट्स, मोस्ट ऑफ द सब्जेक्ट्स, then easily crack means get exam in first attempt. So my miss main intention to every students to first means complete means basic of the every point, then solve means multiple choice question, basic concept clear, so then easily solve means any type of the question. Okay, so quaternary relationship means here professor, slides, then student and course. Okay, this simple quaternary relationship. Then constants in suppose in ER diagram. Okay, so here a number of times an entity of an entity set participates in a relationship set is known as suppose cardinality. Okay, so in constant also means mapping cardinality constant is a one type. So here one to one, when each entity in each entity set can take part only once in the relationship. So one to one means here one simple example. Here person is a one entity, passport is a one entity, has is a one relationship. Person entity, passport entity, and has is a one relationship. So one person, one passport. One person, one passport. These are one-to-one relationships. So for example, Manoj is a person and one suppose passport of the Manoj. So one person, one passport. This is a one-to-one means relationship. Simple. Here M1 to R1. M1 to R1 is a one set. This is a one set. This is a one set. This is a one set. Right. M1 to R1 one-to-one relationship. M2 to R2 one-to-one relationship. M3 to R3 one-to-one relationship. R1 to F2 one-to-one relationship. R2 to F1 one-to-one relationship. R3 to F3 one-to-one relationship. Simple. Okay, this is an example of the one-to-one relationship in ER diagram. It's a mapping cardinality. So simple ER diagram here. Person, passport, and here one-to-one relationship. Simple. One to many relationship. Here simple example. It is a one entity. Customer is a one entity. Then here order is a one another entity. So here customer, one customer means ki many order. One customer provide many order. Okay, means is a one to many relationship. Ki one to many. So here means here write one or here type one. Suppose in exam, suppose ki any ER diagram in GATE exam, and so for example any type of the question, so easily understand the relationship. This is a one to many relationship. So here S1 is a one entity. Here means sorry, S1 is a S1 to R1, and S1 is a R2 is a 1 to many relationship. Then S3 to R3, 1-to-1 relationship. S4 to R4, 1-to-1 relationship. So S1 entity to R1 entity or S1 to R2 entities is a 1 to many relationship. This simple example of the 1 to many relationship. Then next is the many to one relationship. So many to one simple example here, when entity in one entity set can take a part only once in the relationship, then set an entity in other entity set can be take part of the more than one in the relationship set. For a simple example, so a student is a one entity, then course is a one entity, and enroll is a one relationship. So many student means ki teach one course. The example, suppose in this class, suppose IT students, some computer students. For example, many students teach, suppose example suppose a database course of the gate. Okay, so many student to one course. Okay, this simple many to one relationship. So here simple example, R2, R3 and R4 this entity use this C3. This is a many and this is a one. C3 is a one. So many to one relationship in ER diagram. Many to many. So it is represented as n. N means ki many. Here n means ki many. So student and course. So many student, many course. So many student means ki teach many course, or many students enroll for the many courses. This is a many to many relationship. Okay. So it's simple. Here one to many and here many to one. So many student enroll in many courses. This is an example of the many to many relationship. Then a participation constant. So here means two types of the participation constant in ER diagram. One is a total participation and second one is a partial participation. Total participation means, one simple example is, suppose student is a one entity. Listen carefully, is a very easy. Student is a one entity. Course is a one entity. Okay. Suppose example, suppose B computer, suppose 68 students. Consider as a B computer, suppose 68 students enroll in, suppose example, DBMS course. Okay, course is a DBMS. So many students, all 68 students enroll for the DBMS gate exam. And suppose example join for the means a particular DBMS course is a total participation. But in case suppose out of 68 only suppose 30 students join for the DBMS lecture, so it's a partial participation. So total participation means suppose many students, so for example 10 students who means enroll for the these courses. Okay, so okay, total participation. Then suppose example out of 10 students only suppose example 5 students enroll, this is a partial participation. One simple example, suppose bank, suppose particular in bank, suppose account number is a one entity and loan is a one entity. In bank, suppose SBI bank 10 accounts. So consider the 10 accounts in SBI bank, and out of 10 accounts, so for example all 10 customer take loan. So for example 10 customers and all 10 customer has loan. Okay, so here simple, this is a total participation. But suppose in SBI bank 10 customers, and here suppose example out of 10 customers only take means only 5 persons loan, remaining 5% no loan. So simple partial participation in EI diagram, and it is denoted in this line. Okay, it specifies that each entity in the entity set must compulsorily participate in at least one relationship instance in the relationship set. That is why it is called as mandatory participation. A total participation is represented using the double line between the entity set and relationship set here. This line means ki total participation. Okay, the single line between the entity set course and relationship set enroll in significant partial participation. It specifies there might be exist some courses for which no enrollments are made. Okay, so suppose example 5 courses and suppose student, so all courses suppose example register, suppose example roll number one of the T computer class enroll for the all courses of the gate or attend all lectures of the all subjects of the gate is a total participation. When this roll number attend only suppose 2 to 3 subject lectures, is a partial participation. Simple, and it is denoted in this line. Double line means ki total participation. Simple. Same for partial participation. Then key. So actually key is a very important part in a database system. Okay, so in key in a DBMS as an attribute or set of the attribute which helps you to identify a row in a relation. The super key. A super key is a group of the single or multiple key which identify the rows in a table. A super key may have additional attributes that are not needed for unique identification. Roll number is a super key or roll number name is a super key. So already in lectures discuss all keys because in database important part is a key. So a simple example, suppose student is a one entity, roll number, then name, then address, and then mark. These are some attributes of the student. And in this example, suppose roll number is a key attribute. As a means any entity, as per the requirements, one key attribute is available. So a student a roll number is a key attribute. Okay. Then here, find out the super key of this relation. Super key is what? Roll number is a key attribute. So as per requirement, roll number is a super key. No problem. Roll number is a super key. Okay, my requirement ki roll number is a super key. Second, suppose super keys as per the requirement means user requirement. Roll number, comma name is a super key. No problem. Roll number and name is a super key because here key attribute available in this set. Roll number is a key attribute of this relation. So roll number is a simple. Roll number is a key attribute. So in this set, roll number and name is a combine. So this roll number and name is a super key. No problem. Then roll number, then name, then address is a super key. Yes, no problem. Because here key attribute available here. So roll number is a key attribute. No problem. Then roll number, then name, then address and mark. This is a super key. No problem because in this set means key attribute is available roll number. So I think this is super key concept. Okay. Then suppose candidate key. Suppose decomposition of the student. Suppose student one. Here roll number, name, and suppose address. The decomposition. And suppose here student 2, get lecture, get. So here student 2, so here roll number and suppose here mark. Okay, so here simple student 1, so roll number, name, and address. So roll number is suppose key attribute. The roll number is a key attribute. So roll number is what? Super key. Then suppose roll number is a suppose candidate key. Okay, what is candidate key? Candidate key is a minimal super key. Okay, and here Q1 concept also required in normalization concept in future because in our syllabus also get syllabus also normalization concept point. So roll number is a prime attribute. This roll number is a what is prime attribute? This is part of the candidate key. So roll number is suppose candidate key. So roll number is a prime attribute. And what is mark? Mark is a non-prime attribute. Mark is a non-prime attribute. Okay. And what is the condition of the second normal form? Non-prime attribute is fully dependent on the relation key. Then particular database or particular database in second normal form. Okay. Condition is what? Non-prime attribute is fully dependent on the relation key. Okay. So relation here means non-prime attribute is roll number. Sorry, mark is a non-prime attribute. Is dependent on this roll number. Okay, no problem. So mark is a non-prime attribute dependent on this roll number. So roll number is a key attribute. So this particular decomposition or particular database in second normal form is the one condition, and no partial dependency here. Here direct no partial dependency available here because this mark is directly fully dependent on this key. Directly dependent on this key. So there is no partial dependency. So particular decomposition in second normal form is a concept in normalization. Okay. But actually here आपण काय पाहतोय in suppose in our point. So key, I think super key. So no problem in super key. So no problem in super key. So super key is a group of the single or multiple keys which identifies rows in a table. A super key may have additional attributes that are not needed for the unique identification. Okay. So here roll number, name, and address. So roll number is attribute, name is attribute, and address is attribute. Suppose roll number is a key attribute. Roll number is a key attribute. So roll number is a super key. or roll number name is a super key. So here group, roll number and name is a group, so roll number is a super key, roll number and name is a super key because key attribute available in this set. So roll number is a key attribute, is a super key concept. Okay. Candidate key. What is candidate key? It is a set of the attributes that uniquely identify tuples in a table. Okay, no problem. Candidate key is a super key with no repeated attributes. Candidate key is a super key with no repeated attributes. Okay, correct. The primary key should be selected for the candidate keys. Every table must have at least a single candidate key. Yes. A table can have multiple candidate keys, but only single primary key. In database concept, suppose one table is available, so in one table maximum one primary key. In one table maximum one primary key, but actually in case of the candidate key, so there are multiple candidate key in one table, no problem. So multiple candidate key is possible. Then properties, it must contain unique values. Yes. Candidate key may have multiple attributes. Yes. Must not contain null values. Okay, null values not allowed in suppose candidate key. It should contain minimum field to ensure uniqueness. Yes. Uniquely identify each record in a table. Okay. But actually in candidate key is a normal definition of the candidate key is a minimal super key. Candidate key is a minimal super key. Okay. So your roll number name is a candidate key. Suppose here roll number name is a candidate key. So roll number address not a candidate key because roll number name is suppose super key in super key. Suppose roll number and name is super key, then roll number name is candidate key. No problem. But actually roll number and address not a candidate key. Okay. These are the two keys normally required required in normalization concept. Super key, candidate key, prime attribute, non-prime attribute. Okay. Third type of the key is a primary key. Okay, so primary key is column or group of the column in a table that uniquely identify every row in that table. Means primary key, suppose as a consider as a one any example, suppose your roll number as a primary key. So some constant of the primary key means duplicate values not allowed, only unique values is the first condition. Second condition, null values not allowed in primary key. Yes. And third condition, maximum one means primary key available in every relation or every attribute. तर आपण पॉइंट कोणता पाहतो ER diagram. In ER diagram, suppose student is a one entity, roll number, name and address is the attributes of the student entity. So roll number is a primary key. So underline in ER diagram, underline roll number. So this roll number is a primary key. Okay. The primary can't be duplicate, meaning the same value can't be appear more than one in the table. Yes. Cannot have more than one primary key. In one table, maximum one primary key. Okay. So the rules for the defining primary key, two rows can't have the same primary key value. Yes. Duplicate value is not allowed. It must for every row to have a primary key value. The primary key field cannot be null. So blank value is not allowed in primary key. The value in primary key column can never be modified or updated if any foreign key refer to that primary key. Yes. So in this example, roll number is a primary key. So roll number is a primary key. Roll number name is a primary key. Yes, no problem. In one table, maximum one primary key. Either roll number is a primary key, no problem. But in case, two types of the primary key composite primary key and single attribute as a column level primary key and table level primary key. So a roll number is a suppose primary key, no problem. But in case suppose some users say no, only roll number, no primary key. In my relation, suppose or my table, roll number and name is a composite primary key. Yes, no problem. As per the requirement, roll number and name is a primary key, no problem. As per the requirement, roll number is a primary key, no problem. But one condition, in one table, either roll number is a primary key or the roll number name is a primary key. At least one, only one primary key means support in suppose one relation or one table. Foreign key, foreign key is a column, means here compulsory requirement of the foreign key, so here required primary key. Primary key is available in one table, so second table, suppose one table roll number is a primary key, so second table roll number is a foreign key is possible. And foreign key, some conditions, duplicate values allowed in foreign key, null values means allowed in foreign key. Okay, so simple here, foreign key is a column that create a relationship between two tables. Means here required primary key is the first requirement of the foreign key. The purpose of the foreign key is to maintain data integrity and allow navigation between two different instances of the entity. So one simple example is a table 1, this is a table 2. Two tables available with me. So first table name is what? Table 1. Second table is a table 2. So simple, a roll number, name and address is the attribute of the first table, and here roll number is a primary key. Here roll number is a primary key. So primary key means ki duplicate value is not allowed in roll number field attribute. So 101, 102, 103 is a unique values in roll number. Second table roll number is what? Foreign key. Okay, so here duplicate values allowed in foreign key. So here 101, 101, yes, duplicate values allowed in foreign key. Then 102, yes, allowed. But in case, suppose here insert 104, so not allowed. Means here insert only those these records available in primary key. So 101 available here, so 101 insert many time, no problem. 102 available here, 102 insert many time, no problem. 103 available here, 103 insert many time, no problem. But here 104 not available in primary key, and suppose here insert 104, then get error message because parent key not found. So 101 is a child key, here 101 is a parent key. So here insert 104, so here get error message because parent key not found. Okay, and here means here allowed duplicate values is the one reason. One simple example of the banking system. Also, for example, in suppose library system, suppose roll number 101 is the one roll number, and this roll number suppose in library suppose issue suppose DBMS course book for the get exam purpose. So one transaction in library 101 student, suppose example ABC student, and get suppose course book for the DBMS study purpose, get exam purpose. Okay, same roll number 101 to after means 1 hour, you take second book in library. So for example, operating system, suppose Galvin book for the get exam purpose. Okay, so here 101 first entry is what? Course book of the DBMS. 101 roll number second entry, Galvin book of the Galvin book of the means operating system. Then 101 roll number after 1 hours त्यांना अजून एक बुक पाहिजे. So 101 suppose computer network. So that means 10 mm book take from the library and to 10 mm for the get exam purpose or frozen book. So here 101 three entries. But actually in first table, main student table, roll number is what? Primary key. So 101 suppose Manoj. So Manoj take three books. Here 101 take suppose example is a book name suppose is attribute. 101 take course DBMS book for get exam purpose. 101 take DBMS book, Galvin book for the operating system purpose. 101 take and to 10 mm book for the computer network purpose or Horizon book for the computer network purpose. These are the some standard books for the specific core subjects. Okay, so this simple. So this simple means ki foreign key concept. So foreign key allow duplicate values. So this example in every project require this foreign key and primary key. Okay, means ki most of the project of the database prefer foreign key and primary key. Okay, the simple foreign key concept. Then extended entity relationship model. So here till here means it cover some basic concepts of the ER model, and so also here means it cover extended ER means model. So extended entity relationship model. So here means 3 points. Main point is a specialization, and specialization is a 1 point. Generalization is a 1 point, and third is the aggregation. Okay. So in what is specialization? Specialization means higher level entity to lower level entity. One simple example in extended ER diagram, I think all of you know inheritance concept. In inheritance, base class, derived class, this concept is available in inheritance. So some property of the base class access in derived class. In inheritance in object oriented programming, some base class properties access in derived class. So this simple inheritance concept. Okay, so same concepts here used in ER diagram. Suppose higher level table or higher level entity, suppose ki some attributes used in lower level entity. This concept is a suppose extended ER features, and here support these three features. First one is a specialization, second one is the generalization, and third one is the aggregation. Okay, so simple here. ER is a high level data model that incorporates the extension to the original ER model. Okay, so EID are the high level model that represent the requirements and complexity of the complex database. Okay, so your concept is a subclass and superclass concept in extended ER feature. So concept is a specialization, generalization, and aggregation. So specialization means ki top down approach, means ki higher level entity to the lower level entity, means ki higher level entity first use, and then some attributes of the higher level entity use in a lower level entity. One simple example, suppose VPKBIT is one college. So in this college, college is a one entity. College is a one entity. Second entity is a suppose faculty. Faculty is a one entity, and third entity is suppose student entity. So college depends on faculty. Okay, in case no faculty in college, so college not work. No faculty in college. Okay, so college depends on this faculty. Faculty depends on student. No students in college. No admission in college. So college not work, or student means faculty not work. So here dependency means कि higher level entity to the lower level entity means college to faculty, faculty to suppose student. So this concept is called as simple specialization. Okay, and generalization means कि lower level entity to the higher level entity. One simple example, student to faculty. Dependency student to faculty. Student is a lower level entity, then faculty is some higher level entity. Student to faculty, and faculty to suppose college. Means here means bottom up approach. Top down approach means simple specialization. Bottom up approach means ki simple generalization. Bottom up approach means ki here generalization. Okay, so here types of the specialization. So overlapping specialization, disjoint specialization. Okay, these two types. So here means actually an example discuss. So in this example, this is one simple ER diagram. Okay, and here suppose use concept of the specialization. Okay, so what is specialization? Specialization means ki higher level entity to the lower level entity. So person is a higher level entity. Person is a higher level entity. Employee is a lower level entity. Customer is a lower level entity. So one person means higher level entity to the lower level entity is a specialization. And specialization here use one relationship is a relationship. So person is a employee. So person is a customer. So person is one higher level entity. So name, street, and city. So here in employee, employee is a lower level entity. So salary. So employee attribute means employee refer attribute as a name here directly, no problem. Employee refers to a street, no problem. Employee city directly here use as a concept of the inheritance. Here customer take name, customer street, customer city. So simple example of the specialization. Then suppose here employee is a officer, employee is a tailor, employee is a secretary. Okay, so employee is a higher level entity, officer is a lower level entity. So some attributes of the employee refer here office number. Okay, so employee is a salary. Then here means access this suppose salary attribute here, officer, name access here, street access here, city access here. Then here tailor. So tailor access here salary, then name, then street, then city. Okay, then secretary access here name, then street, and city. So this concept is called as simple specialization. Specialization means ki simple higher level entity to the lower level entity. So this example is a simple specialization concept in ER diagram. Okay, what is means ki generalization means ki lower level entity to the higher level entity. This is means ki generalization. Okay, okay, okay. 1 minute. तीन फिल मीन्स की डीबीएमएस लेक्चर मीन्स की फीडबॅक फॉर्म ओके मीन्स की जेव्हा तुम्हाला हे करायचं असेल तेव्हा तुम्ही फिल करा हा फॉर्म ओके मीन्स इन लेक्चर Okay, so start with the remaining point of this lecture. So this specialization means ki top down approach. Okay, means ki person, employee. Okay, a person is a higher level entity, employee is a lower level entity. So person is a means what is specialization? For specialization means ki top down approach, and suppose generalization means ki bottom up approach. So he explain here means ki generalization. So here officer, teller, okay, is a lower level entity. So lower level entity to the higher level entity is a means ki generalization. Then suppose secretary, teller, means ki suppose lower level entity to the higher level entity. Okay, simple is a simple generalization. Then here employee is a person, customer is a person. Okay, so last year means ki one student is a Anuj Fulari student, right? So in Anuj Fulari means ki attend all lectures with every means ki points of my DBMS lecture, and he get means ki 64 rank in suppose in GATE exam. So this student means ki very talented student and attend each and every point and means ki very good result in GATE exam. So I think here means ki very less attendance माहित नहीं है का. Okay, means here means free of cost your means classes is available, then attendance is very poor. So GATE exam passing is very easy. की थोडा स्टडी केला तर तुम्ही इझिली मीन्स क्रॅक करू शकता एक्झाम. पण स्टुडंट आय थिंक काय इंटरेस्ट करत नाहीत माहित नाही. ओके, सो नो प्रॉब्लेम. ओके, जे आहे त्यांच्यासाठी गुड. ओके, नो प्रॉब्लेम. सो हे पर्सन इज मीन्स की हायर लेवल मीन्स स्पेशलायझेशन अँड जनरलायझेशन आय थिंक नो प्रॉब्लेम. Then generalization means here discuss. Okay, no problem. So attribute inheritance means ki suppose ki some attributes of the higher level means ki suppose entity to access in lower level entity is the attribute inheritance. Constraint on the generalization is a conditional defined. Conditional defined means ki suppose particular. Ki suppose a conditional defined means ki lower level entity sets membership is evaluated on the basis of the whether not means ki explicit condition or predicate condition. One simple example. Suppose here person is a one higher level entity and only suppose person is a employee. Person is a employee, so this is simple disjoint. Disjoint means a condition. Simple. Okay. Then here coverage based means disjoint constraint. Disjoint constraint means only one higher level entity, only one lower level entity means a disjoint constraint. Total generalization or specialization. Total generalization means ki suppose in higher level suppose in this example same, in this example 10 person, 10 person and 10 employee, 10 person, 10 employee, so total specialization. 10 person, 5 person is a employee and 5 person is a customer, partial generalization. Suppose 10 employees and all 10 employees is a person. Okay, ठीक है, total generalization. 10 customer, 10 persons, total generalization. Simple. It means here point is a what? Total generalization or specialization, partial generalization or specialization. Simple. Means each higher level entity must belong to a lower level entity set is a total generalization or specialization. Partial generalization special means some higher level entity may not belong to any lower level entity. This simple total generalization and partial generalization. Okay. Then aggregation. So main purpose of the aggregation to reduce relationships. So in this example, employee is one entity, job is one entity, branch is one entity, manager is one entity. So here simple, the number of relationships available here. Means employee works on job, employee works on branch, employee manages manager. Okay, then manager manages branch. So here number of relationships available in this diagram. So main purpose of the aggregation to reduce relationships. So here means reduce relationships of this diagram. So the simple example. So here reduce relationships. So employee, then branch and job in a one set is a one higher level entity. Suppose is a one higher level entity is a combine. Manage is a only one relationship and manager is a lower level means suppose entity. So here only one relationship. So employee manages manager, job manages manager, branch manages manager. Okay, so here simple higher level entity to the lower level entity. So main purpose of the aggregation to reduce relationships in ER diagram. So simple here schema diagram of the university database. Okay, schema means what is schema? Overall design of the database. Ki suppose example ki draw ER diagram or suppose example the schema diagram. So here section section is one entity, text is one entity, student is one entity, advisor is one entity, department is one entity, course is one entity, time slot is one entity, classroom is one entity, teachers is one entity, prerequisite is one entity, instructor is one entity. This means all entities ki normally in ER diagram notation means in course book or some these notations are available for the ER diagram or schema diagram. So student entity, text entity, section entity, time slot entity, classroom entity, teachers entity, prerequisite entity, instructor entity. So course ID underline. So is the primary key. Then suppose a miss key attribute. Okay. Then ID is a key attribute. So as per the requirement, miss key design, miss key attribute. The simple example of the schema diagram of the university database. One simple example of the banking system. So bank is one entity, branch is one entity, loan is one entity, account is one entity, customer is one entity. So customer ID is a key attribute. So primary key. So customer is a strong entity. Then bank is a strong entity. Here code, bank code is a means key attribute. Then branch. So name, code, address is attribute of bank. Has is the relationships, loan is a entity, offer is a relationships, maintain is a relationship, hold by is a relationship, availed by is a relationship. Was a simple example. Account number is a key attribute, this is primary key, so here underline. So account entity, account number primary key, customer entity, customer ID primary key. Then loan, suppose loan ID, suppose key attribute. Then bank, suppose this code is a key attribute. Okay, this simple diagram of the banking system. So means here cover as a in our syllabus, in gate exam syllabus, point is hot model. So in model means here cover all basic of the diagram. Okay, and then means in exam some type of the questions available in exam. So this type of the some questions available in suppose in gate exam for the diagram purpose. So which one of the following, listen carefully, which one of the following is used to represent the supporting many to one relationship of weak entity set in an entity relationship diagram? What is weak entity? Weak entity means, weak entity means no key attribute available in weak entity primary key. So it is represented in double rectangle or double diamond, sorry, double diamond. So here four options: diamonds with double bold border, rectangle with double bold border, oval with double bold border, oval with oval that contain underline identifies. So in weak entity set, it is represented in double rectangle. So this answer is correct. Rectangle with double bold border. Normally, suppose strong entity is represented in normal means rectangle, but in case of the weak entity is represented in double rectangle. Okay, so here means the question is hot. Which one of the following is to represent the supporting many to one? This is a great exam question in 2020 exam. Which one of the following is to represent the supporting many to one relationship? Many to one relationship. Many to one means you suppose one simple example. Suppose many customer. Okay, means ki suppose example use one, means ki many to one. So many student use one means only means ki suppose select one course. So means many to one relationship. Suppose example, suppose DBMS course. So many student pick only DBMS course. So many to one relationship. Okay, and here means ki weak entity set in the entity relationship diagram. So weak entity is represented in double rectangle. So directly your answer is what? Rectangle with double or bold border. So this answer of this question, 1 or 2 mark question in gate exam. 1 mark is a very important mark. Okay, so it is a question of the in 2020 exam. Then suppose in 2018 exam one question in entity relationship model. Suppose R is an many to one relationship. R means what is R? R means relation or table. R is a many to one relationship from entity set E1 to entity set E2. Two entity set here, E1 is a one entity set, E2 is a one entity set. Assume that E1 and E2 participate totally. E1 entity and E2 entity participate totally in R, and the cardinality of E1 is greater than the cardinality of the E2. Cardinality of E1 is greater than the cardinality of the E2. Means E1 and E2. 2 means ki set, entity set, and here E1 is greater than, cardinality of the E1 is greater than the cardinality of the E2. Then which of the following is true about the R? So every entity in E1 is associated with the exactly one entity in E2. Okay. Then some entity in E1, some one entity in E1 is associated more than one entity in E2. Every entity in E2 is associated with the exactly one entity in E1. Every entity in E2 is associated with the most of the one entity in E2. So your answer is every entity in E1 associated with the exactly one entity in E2. Means ki many to one here. Here many to one. R is in many to one relationship. So here every entity in E1 is associated with the exactly one entity in E2. This is the answer. Some other questions. Uh, this gives CS 2012 question. Given the basic ER and relational model, given the ER means ki entity relationship diagram and relational model, which of the following is incorrect? Which of the following is incorrect? So here an attribute of an entity can have more than one value is a one option. Second, an attribute of an entity can be composite. Okay. In a row of a relation table, an attribute can have more than one value. In a row of relation table, an attribute can have exactly one value or null value. So here means we identify the incorrect option of this four. So incorrect option of this all four. So here incorrect option is this third option. In a row of relation table, relational table. Row means ki suppose a tuple or record, an attribute can have more than one value. No. Every row has a only one value. Example, roll number, name and address is attribute. So roll number 1, name suppose Manoj and suppose mark suppose 71. Okay, so here simple. In a row of the relational table, an attribute can have more than one value is the incorrect option of this question. The GATE exam 2012 means exam question. Next question in GATE 2008 question of the CS paper. The consider the following ER diagram. Consider the following ER diagram. So here M is a hot entity, P is a hot entity, N is a hot entity. Okay, and here M is a M1, M2, and M3 attributes. So M is a strong entity. Listen carefully. M is a strong entity. Okay. Then what is का म्हणायचं strong? Because here underline for the M1. So M1 is a key attribute. Okay. Then here N is a weak entity because it is in a double rectangle. Okay, it's a weak entity. Means no primary key available here. Then question is what? The minimum number of tables needed to be represented MNP R1 R2. The minimum किती टेबल तयार करू शकतो आपण minimum. So one table for M, yes, because primary key. So M1 is a table. M1, M2, M3 is a one table. Second table P table. Okay, P1 and P2 attribute, and third table N table. Okay, so here N1, N2. Okay, so answer here means 2, 3, 4, 5. So minimum 3 tables means create here successfully. So your answer of this question is 3. The GATE 2008 question in CS paper. Then next question, let E1 and E2. What is E1? E1 is the entity set. E2 is the entity. Be two entities in ER diagram with simple single valued at attribute, and R1 and R2 are two relationships between E1 and E2. So E1 is a one entity, E2 is a one entity, and R1 and R2 are two relationships between E1 and E2, where R1 is one to many and R2 is many to many relationship, and R1 and R2 do not have any attributes of their own because R1 is a relationship, R2 is a relationship. What is the minimum number of tables required to represent this situation in the relationship model? So here means R1 is a relationship, R2 is a relationship, E1 is a one means entity, E2 is a one entity. So a separate one table for the E1, right? One table for the E2, and here use R1 and R2 relationship. So here means one table with some attributes of the E1 and some attributes of the E2. So here means total number of tables required here 3, minimum 3 tables. One for E1, one for E2, and for one using combined, suppose key relationships. So here required three tables. The three is the answer of this question. Then what is the mean and max number of tables? What is the mean and max number of tables required to convert an ER diagram with two entities and one relationship between them? What is the minimum and maximum number of tables required to convert an ER diagram with two entities and one relationship between them with partial participation consent on the both entities? So here minimum means two entities. Listen carefully here, two entities. Okay, because here use relationship, one entity available, second entity partial participation means here two entities available here. Entity one, entity two, and here use means one relationship, right? So one entity, one table, second entity, two table. So as per requirement, my condition satisfied. So minimum two table required. Maximum you minimum first entity one table, second entity one table, and third table you suppose some attributes of the first entity, some attributes of the second entity, and some attributes in case available of the relationship, then design third table. So here minimum required two tables and maximum required three tables. So your option is what? Minimum one, maximum two, minimum one, maximum three, minimum two. So minimum required two entity, two tables, maximum one table of the one entity, second table of the second entity, and one using the relationship attribute or both entity. So the answer is what? Minimum two, maximum three. It's a GATE 2017 question. Which symbol denote derived attribute in ER model? It's a very easy. In ISRO one exam, this question. Which symbol denote derived attributes in ER model? Double ellipse, dashed ellipse, squared ellipse, ellipse with attribute name underline. Okay, so derived attribute example, date of birth. Date of birth is one attribute. Using date of birth, derived attribute is a age. So it is denoted in the dashed ellipse. So dashed ellipse is the answer of this question. So I think here Missy cover ER model point. I think no problem. I think no problem in ER model. Okay, this is Missy first point of the today's lecture. So second point discuss is a relational model. It is an important point because sometimes some questions on the ER model, some questions on the relational model compulsory in GATE exam to fix the questions on the ER model and relational model. So I think miss here miss cover miss all details of the ER model. Okay, because here miss cover all points, so easily solve any type of the question in ER diagram in GATE exam, no problem. Second is the relational model. A relational database consists of a collection of tables, each of the which assign a unique name. Okay, so what is relation? Relation means a table. And what is relational model means here two or more table or two or more relation. 1 minute. So here in relation means ki table, a relational model means here two or more table. A relational database consists of a collection of a table, each of which assign a unique name. Relational model represent the database as a collection of the relations. If any question, then directly ask, no problem for the means ki any point. Okay, means any question regarding means ki suppose in means points की no problem, or means की chat box मध्ये type केलं तरी चालेल, or ask directly, no problem. Okay, then a relation is nothing but a table of values. Every row in the table represents the collection of the related data values. Yes, relational model, the term relation is used to refer to a table, while the term tuple is used to refer to a rows. Similarly, the term attribute refer to column of a table. So one simple example of the relational model. I think this already covered in regular subject as a relational model some points. So here we just revise in fast because some additional point also is available in this lecture. This point is not in our syllabus in DBMS syllabus in IT and Com. Okay, so this point means one question on relational algebra in GATE exam. So this point also discussed in today's lecture. Relational model means complete fast and then discuss this relational algebra point because one question in GATE exam on the relational algebra and this point not in our syllabus of the DBMS. Okay, so relational model is simple. SID, SName, SH, S class, and S section is the attribute. Okay. So here this is a domain. SID is the one domain, SName is the one domain, S is the one domain, S class is the one domain, S section is the one domain. Okay. And in this relation, suppose 1, 2, 3, 4, 5 tuples. So 1104 is a one tuple, 115 is a one tuple, 1103 is a one tuple, 1102 is a tuple, 1101 is a tuple. So 5 tuples available in my relation. So cardinality of this relation or cardinality of this table is what? 5. Cardinality 5 ka because here 5 records or 5 tuples available in my relation. So for example, 100 tuples available in my relation. So cardinality of this relation is what? 100. Then here degree of this relation is 5 because total number of attributes available in my relation is 5. SID, SName, SH, S class, S section. 1, 2, 3, 4, 5. So degree of this relation is what? 5. Cardinality of this relation is 5. So for example, only 2 attributes in my relation. So degree of my relation is what? 2. Simple degree. Degree 2. The simple basic concept of the relational model. The most popular data model in DBMS is the relational model. They are also known as relation in the relational model. So attribute. So attribute, what is attribute? Set of the permitted value of the specific, means ki suppose one simple example of the student, roll number, name, address is the attribute, simple. An attribute is nothing but the column header of the relation. All the data referred by an attribute are in the same domain. Okay. Attribute value is specific valid value for the type of the attribute. Domain. What is domain? So in this example, SID is the one domain. Then SName is the one domain. SH is the one domain. Then S class is the one domain. Then S section is a one domain. Okay. So domain means a particular set of the permitted value of the particular attribute is called as domain. So SID domain, SName domain, SH domain, S class domain, then S section domain. Then tuple means ki record. So here in this example, 1101 is a one tuple, 1102 is a tuple, 1103 is a tuple, 1104 is a one tuple, 1105 is a one tuple. So simple here, a table in relational model contains a record, which are the horizontal rows in the table. This is called tuples. What is relation? Relation means ki table. So a relation is defined as the set of the tuple that have the same attributes. So here R, A comma B comma C. What is R? R means ki relation, means ki table. A is the attribute, B is the attribute, C is the attribute or column. So R is a relation, R is a relation, and A, B, C is a column name or attribute. It's a simple relation. What is degree? Total number of attributes. Total number of attributes means ki degree of the particular relation. So for example, student table, 2 attributes, roll number and name. So degree is what? 2. Simple. Cardinality means ki total number of tuples available in particular relation or particular table. Student table, 68 entries, 68 record. So cardinality of the student table is what? 68. Simple. Relation key, every row has one, two, or multiple attribute which called the relation key. So as per the means ki requirement, ki suppose student is a one entity, or student is a one table, or student is a one relation. So roll number is a key attribute. Customer entity, so customer ID is a key attribute. So as per the requirement, means ki design means ki key attribute of the specific means ki relation or specific table. So here simple, student ID, name and age is attribute of this relation. Student ID, name and teacher is attribute of this relation. Then student ID of the first relation. Then subject ID of second relation and marks of the second relation. So this simple. Here we cover some attributes of this relation. Here some attributes of this relation. So simple relational model. Okay. RDBMS. RDBMS means ki relational database management system. Okay. So RDBMS. Okay. So advantage of the relational model, simple. This model is more simple as compared to the network and hierarchical model. Yes. Scalable. This model can be easily scaled as well as we can add as many rows and column we want. Yes. Easily scalable relational model. Structural independence in a relational model. Hardware overhead. Overhead is a one drawback of this relational model. Bad design is a one drawback of the relational model. This is an example of the relation model. So ID, name, department name, and salary is the attributes of this relation. So degree of this relation is what? 4. and tuples 2, 4, 6, 8, 10, 12 tuples of this relation. So cardinality of this relation is what? 12, because here 12 tuples available in this relation. So cardinality of this relation is 12. Degree of this relation is 4, because there are only 4 attributes. Okay, correct. Then attribute types, the set of the allowed value for the each attribute is called the domain. Already discussed. Attribute values are required to the atomic, that is indivisible. Okay. The special value null is member of the every domain. The null values cause complication in the definition of the many operations. Yes. Relation schema and instance. So what is A1, A2, A and AN? This required in also in normalization concept. Okay, these are important points in relational model. These points also required in normalization concept. So A1, A2, AN. So A1 is the attribute, A2 is the attribute, AN are the attributes. So what is R? R is a A1, A2 up to AN is the relation schema. Okay. And then instructor is a one relation. ID is the attribute. A name is the attribute. Department name is attribute. Salary is attribute. So these are 4 attributes of the instructor relation, and formally given as a D1, D2 up to DN. D1 is a domain. So ID is a one domain, name is a one domain, department name is a one domain, salary is a one domain. So relation R is a subset of the D1, D2, DN. What is D1? Domain. Means ID is a one domain, name is a one domain, department name is a domain, salary is a one domain. This relation is a set of the n tuples A1, A2, AN, where each A1 belongs to domain. Keys already discussed: super key, candidate key, foreign key, then primary key already discussed. Let K subset of the R. K is a one key. R is, what is R? R is a relation. R is a relation. Okay, and key. So K is a subset of R. R suppose consider as a student. Roll number, name, and address is the attributes of the R, and key suppose roll number. So roll number is a subset of student. Yes. So K is a subset of R. K is a super key of R. If values of the K are sufficient to identify unique tuple of the each possible relation, yes, R of R. R means key relation. Example, ID and ID name are the both super key of the instructor as per the requirement. ID is a suppose key attribute of the instructor. Here, ID is a key attribute of the instructor. So ID is a super key, no problem. ID and name is a super key, no problem. Super key K is a candidate key. K is minimal. K is minimal, then also is called as candidate key. ID is a candidate key for the instructor, no problem, because ID is a key attribute in one relation. So here, one of the candidate key is selected to be primary key. Which one? Foreign key. I think this concept is clear. Primary key, foreign key, candidate key, and super key. This point is important because one question in gate exam, in every gate exam, given question on the relational algebra. So here we see cover some points of the relational algebra. This point is not our syllabus. In our syllabus, this point is not available. Relational algebra. This is a very very easy point, and 1 to 2 mark question in every gate paper. So in ER model and relational model, one question available in gate exam. Relational algebra, one question is available. So fix here means ki 2 to 3 marks minimum. Ki out of 100, 2 to 3 marks easily pick from these 2 points. Means ki today's lecture means ki cover at least means minimum 3 point lecture 3 marks. So 3 marks is a very very important, because in SC/ST student get means ki 18 to 19 marks for passing purpose. So here get 3 marks. So only remaining mark is means suppose only 15 to 16 marks. Open category student 25 to 26 or 27 is a cutoff. So here means 3 to 4 marks easily for these points. Okay, in total DBMS 8 to 10 marks. So out of suppose DBMS subject is all clear means तुम्हाला सगळं येते, right? So easily get 8 marks. Perfect. And only remaining marks is for open category students only means 16, 17 to 18 marks for the other subjects. Okay. So this point is very very important. So listen carefully. So relational algebra point is the last point of the today's lecture. This point is end, then means today's lecture is finished. Okay, no problem. So what is relational algebra? She created a Eager F code at the IBM in 1970. So Cod is the one scientist in 1970 means work on this relational algebra, and here means he provides some these notations. So it is a procedural language. So 6 basic operations in relational algebra. 6 basic operations in relational algebra. So first one is a select. It is denoted as a sigma. Second one is a project pi. Third is a union. The next one is set difference. Next one is a Cartesian product, and last is a rename. Okay. So I think all of you know in normal SQL query. Suppose display all records of the student table. So your query is what? Select star form student. So here display all records of the student table. Suppose display roll number one record in student table. Normal query in database. Select star form student where roll number is equal to 1. Correct? But in case of the relational algebra, we suppose display all records of the student table. So here use operation select. Suppose display all records of the student table. So use operation in relational algebra is a select and it is denoted as sigma. If suppose student is a one table, a student is a one relation, five records in student relation, and suppose display all records of student relation using relational algebra. So here use select operation as it is denoted as a sigma notation in relational algebra. Okay, suppose display roll number one record in relational algebra, not in SQL, not in relational model. In suppose not in suppose database. So here use this sigma operation and here means a condition where roll number is equal to 1. This is simple relational algebra expression. Second one is a project operation as it is denoted as a pi. Project operation it is denoted as a pi. So I think all of you know, suppose student is the one relation. Student is the one relation. So roll number, name, and address is the attributes of the student relation. And here suppose okay, identify or suppose display is suppose roll number and name. Roll number and name of the student relation. So here means relation means roll number. What is roll number? Attribute. What is name? Attribute. The specific attribute display करायची असतील, right? So here pick or here use as a project operation. means की pi. की suppose display student table roll number name address mark age five attributes only display roll number and name. So here use project operation projection operation project roll comma name form relation suppose student. So here display only roll number and name operation roll number and name records. So main purpose of the select operation it is denoted as a sigma and here use for select query purpose here use this sigma operation. Project operation also used for the select purpose, but actually this project select only attributes. कि suppose student table, roll number, name and address attribute. So only display roll number. So he queries project, roll number and suppose student. पण actually in normal database आपण कसं करतो in select roll number form student where roll number is equal to 1 or select roll number form student. So these two operation is a very important. First one is the sigma operation. Second one is the project operation. Third, I think all of you know union is a union operation. Okay, so union is in normally in database here use union keyword. Normal database here use union keyword in set operators. Suppose select name from student 1, union keyword, select name from student 2. So it's a union operation, normal database. But actually in relational algebra here use this notation for the union purpose. Okay, set difference means ki minus. In normal database you use select name from student 1 minus keyword select name from student 2. It's a normal database operation as a set operator operation, but actually in relational algebra here use this minus operation, this notation for the set difference purpose. Cartesian product purpose this point this notation. Okay, and normally in Cartesian product query suppose आपण केलं होतं in view मध्ये suppose create view v1 or suppose normal simple example of the Cartesian product two tables student 1 and student 2 table. So select star from student 1 comma student 2. So it display all record of the student 1 and student 2 with Cartesian product. But actually this Cartesian product used in relational algebra. So here use this notation, this multiplication symbol, this cross notation. And rename rename operation we suppose table name is student and suppose change the name of the table, change the name of the table. So here use rename operation and this noted as the row, this symbol. Using this symbol means ki suppose ki rename the operation. So relational algebra only these six operation, but actually here की one question in gate exam आपण हे deep मध्ये पाहणार आहे with one example of the every operation in relational algebra. So select purpose use sigma, project purpose use pi, union purpose use this notation, set difference purpose use minus, Cartesian product purpose use this, and rename purpose use this. So the operators take one or two relations is input and produce a new relation as well. So only discuss one example of the every operation in relational algebra, not in relational model, in relational algebra. Okay. So here first example of the relational operation, sorry, select operation in relational algebra. This is a one table. What is A, B, C, D? A, B, C, D is the attributes. Is the one relation, one means row, two row, third row, or four tuples. Okay. So notation is what? Select P of R. What is R? R means की relation. R means की this relation. हे relation ला काहीतरी नाव असेल. So this relation is a R. Then P is defined as the selection predicates. So simple here query defined as select P of R, select P of R. Okay, this is actual tuple relational calculus example. पण actually आपण कोणतं स्टडी करतोय only here study as a not tuple. Here means study only relational algebra. So here relational algebra query here. This is a relational algebra query. This is a tuple relational calculus आपण नाही पाहिलं अजून. So means की today's lecture means की mainly focus on the only relational algebra and next lecture means की tuple calculus. Okay. So here simple. What is sigma? Sigma means what? Select. Department name. Department name मला choose करायचे right. So here department name is an attribute. Okay, is equal to physics. Select department name is equal to physics and instructor is one relation name. This is simple syntax. Select department name is equal to physics and instructor. जर मला याच्यावरती अप्लाय करायचं असेल तर ABCD is attribute. So select AB is equal to suppose alpha and bracket suppose R. So here select department name is equal to physics instructor. So this is a select query in relational algebra. Department name ज्याचं physics आहे तो रेकॉर्ड मला डिस्प्ले करायचे फ्रॉम इन्स्ट्रक्टर रिलेशन. सो the output is what? All physics record of the instructor relation. Okay. Then here suppose select A is equal to B or D is greater than 5 of R. This syntax. So in bracket put up relation name. Here actually condition and using this condition display all records of the student table. So here this is the first operation is a select. Select means ki sigma. As per the condition means ki display records of the record or tuples of the particular relation. So here select department name is equal to physics and here instructor is a relation name. Simple. Then project operation means ki main purpose of the project operation means ki pick a particular attributes of the pick particular attributes of the particular relation or display particular attributes of the particular relation. So use project operation. Okay. So in project operation notation is what? Pi. A1 means what? Attribute name. A2 means attribute name. AK means attribute name and R means की relation. कि suppose in student table suppose suppose student table suppose roll number name and address is the attribute and this is suppose display in using project operation using relational algebra. So query कशी असेल? Pi of roll number comma name in bracket student. Pi roll number comma name in bracket student. This means की project operation in relational algebra. Okay. So here A1 and A2 are the attributes. Here A1 is attribute, A2 is attribute, and names and R is a relation name. R is a relation name. Okay. So here simple. The result of the defined as the relation of the K column obtained by erasing the column that are not listed. Then here duplicate rows remove from the result since the relations are sets. So here is simple example of the actual example. Instructor is one table or relation. ID, name and salary is the attributes of the instructor relation. And suppose display only ID, name and salary of the instructor relation or instructor table. So this is a MISC relational algebra query. Pi. ID is the attribute, name is the attribute, here salary is the attribute and here instructor is the relation. Okay. So here display means ki all ID, name and salary of the instructor relation. This is a query of the relational algebra query, not normal database query. And normal database query कशी असेल? Select ID, comma name, comma salary from instructor. When this query of the SQL query and this is a simple relational algebra query. Pi. Pi कशासाठी वापरायचं? Display specific attribute and sigma specific record purpose. Record purpose use sigma and attribute purpose use pi. Simple. So here Missy query is what? Pi of a comma c of r. Pi of a comma c of r. So here simple. What is a attribute? What is c attribute? What is r relation? Simple. union operation. So union operation, R union yes. Okay. So simple. R union yes is a means this is tuple relational calculus आपण आता नको पाहिला. Only means here to see the relational algebra query. Okay. So here exam to find the all courses taught in the fall 2009 semester or in the spring 2010 semester or in both. So here pi, what is purpose of the pi? Select attribute. Pi course ID. Inside select specific record. Sigma semester is equal to fall. Okay. Here condition and condition year is equal to 2009. Select section. Here union for this statement purpose use this query. Pi course ID. Pi means ki select only attributes as a course ID. Select means ki select record and record means here semester is equal to fall and condition and operator जसं आपण वापरतो query मध्ये and year is equal to 2009. Section is a table name or relation name. Union याचा result union second चा result. Pi course ID select means here semester is equal to spring and operation year 2010 section. That means ki and query sorry union operation in suppose relational algebra. And normally simple मला करायचं असेल suppose student 1 is a one table. Suppose student 1 is a one table. Student 1 is a one table. So roll number and suppose name. Okay, in first table. Student 2 suppose second table. Roll number and suppose name. Same attribute name. And here suppose example use this project union operation on this here. तर कसं करणार for this specific pi of name in bracket student 1 union pi of name student 2 finish union operation query pi of name and here bracket instead of this section हे बाकीचं काही गरज नाहीये pi of name sectionच्या ठिकाणी student 1 union pi of name suppose student 2. So output of this query is what? Union result. जसं आपण query मध्ये पाहिलं होतं select name from student 1 union keyword select name from student 2. So directly here means retrieve common value single time. So here pi of name student 1 union pi of name student 2. Simple. And here simple here suppose AB is a one suppose relation, R is a one relation, S is a one relation, and here R union yes. R union yes, and here B is a common. AB is a common in both. So alpha 1 here, alpha A value, B value is 1. Means suppose simple example here, R is a one relation, S is a one relation. So R value is what? R A value is what? Alpha, B value is what? 1. Okay, so alpha 1 here as it is because union operation. Alpha and 1 available here? No. So only single value, so take here. Alpha 2 here available alpha 2 yes. So in both set or both relation alpha 2 is available. So union of this both is alpha 2. Okay. So single time. Then beta 1 available here beta 1 no. So beta 1 take here. Then alpha 2 already miss here cover. Beta 3 so here beta 3 miss here remaining beta 3 is not available in this relation. So beta 3. So this is a result of union. Okay, R1 union yes, this is a R relation, this is a S relation, and here result is a R union yes. I think this is a very easy union operation. But actually here for suppose query of this query करायची असेल तर कसं करणार query of this pi of a comma b pi of a comma b in bracket this R union pi of a comma b in bracket yes. So get this result. Okay, the union operation in relational algebra. Set difference operation same as a minus operation in database. कसं करू suppose example two tables same table suppose student 2 student 1 is a one table student 2 is a table. So normally in SQL query is what select a star form, sorry, not a star, select name form student 1 minus select name form student 2. Okay, so simple SQL query. And in relational algebra, so instead of this select, here means pick name attribute, right, of first table. And here suppose example, take name attribute. तर तो सिम्बॉल मला इथे ड्रॉ करताना मी पाय लिहितो त्या सिम्बॉलच्या ऐवजी पाय. ओके, सो क्वेरी इज व्हॉट, पाय रोल नंबर, सॉरी नेम, नोटेशन मला ड्रॉ करता येत नाही इथं की नोटपॅड, मीन्स पी आय पाय नोटेशन नेम फॉर्म student 1 is the one relation minus pi of name from student 2. Simple. This query is a normal query, SQL query, and this query is a relational algebra query. Okay, so the simple minus operation, and minus operation means simple. In case suppose here name is available in student 1, name is suppose student 1 name, suppose Manoj, Sachin, Virat. Name of the student 1, student 2 name suppose Virat, then Rahul, okay, and suppose Ajit. Okay, so same here. The minus operation means here except common remaining display of the first table, first relation. So common is what, Virat. Virat is a common in both. So output of this pi name student 1 minus pi name student 2. So Manoj and Sachin is the result of this relational algebra query. Suppose here student 2, here student 1. Then here result is except common remaining display of the second table. So here Virat is a common in both. So output of this query is what, Rahul and Ajit. Rahul and Ajit is a query of the this means suppose relation. Okay, so this is a simple SQL query, this simple relational algebra query. Okay, set difference operation in suppose in relational algebra. Same here example, R is a one relation, S is a one relation, then R minus S. So simple here same. Projection means pi, course ID of the first table, select semester is equal to fall, and operation year is equal to 2009, section is a one relation, minus pi course ID, select semester is equal to spring, and year is equal to 2010, section. This is a minus operation query. And this query for this example, query कशी असेल, pi of a comma b, pi of a comma b in bracket r minus pi of a comma b in bracket s. Means simple here query कशी असेल, pi of a comma b, first relation name is what, r, pi of a comma b, and here yes is a query for this relation. So here r minus s. So here alpha and 1, alpha 1 is a one entry here, alpha 1 available here. What is set difference, except common remaining display of first relation. So alpha 1 available here, alpha 1 not available here. Okay, so minus होणार नाहीये, so alpha 1 display as it is here. Alpha 2 available here in first relation, alpha 2 available here, but here both common, so except common, so it is cancel. Beta 1, so beta 1 available here, no, so display here beta 1. So this is the result of the set difference operation in relational algebra. Okay, r minus s. Suppose s minus r, suppose s minus r, so result alpha 2 common here, alpha 2 this cancel, alpha 2 cancel. Beta 3 available in here, here available, no, so beta 3 not available. So result of this s minus r is what, only beta 3. This is set difference operation in relational algebra. Okay, Set intersection operation. I think all of you know intersection in suppose normal in SQL. So normal query is what? Select name from student one, intersect keyword, intersect, select name from student two. This is a SQL query for intersection operation. Okay. Then here student one, two, student one this record, student two this record. So intersection means only common. So Virat is a common. So output of this query in SQL is a Virat. Okay. But in case of the relational algebra pi a comma b, so here r and here this notation. Notation is what? This उलटा u. तर इथं मला ड्रॉ कसा करायचा उलटा u याच्यामध्ये. So this opposite u. Suppose here u opposite u here means ki here pi a comma b r u means ki intersection pi a comma b suppose s. This means ki actual in relational algebra query. So in relational algebra query here use this. R is a one relation, S is a one relation, near R intersection yes. So R, so alpha 1 available here, alpha 1 available here, no. So only common display in set intersection. So no display. Alpha 2 available in first relation, alpha 2 available in second relation. So here common in both relation. So display alpha 2. So result of this is alpha 2. So S intersection R, so same result. Alpha 2 here common. So common display here, beta 3 not available here. So only display here alpha 2. Is a set intersection operation in relational algebra. Cartesian product operation. Okay. In Cartesian product, suppose simple example. In Cartesian product, it is denoted as a notation as a this cross notation. So here in simple in Cartesian product in get exam ki sometime question on the Cartesian product. Okay, so Cartesian product means ki simple first relation, total number of records available in first relation is what? 1 2. Listen carefully, very easy. 1 and 2 records in Cartesian product. Second relation yes, total number of records or tuples 4. 1 2 3 4. Here first relation 2 entries, second relation 4 entries. 4 into 2 8. 4 into 2 8 means r into s केलं तर मला टोटल नंबर ऑफ मीन्स की टपल्स किती मिळणार आहेत 8. सो हिअर पहा 2 4 6 8. पहिली एंट्री काय याच्यामध्ये पहा अल्फा 1. सो दिस अल्फा 1 a 10 a 10 a alpha 1 a 10 a is the first entry. Alpha 1 b 10 a is the second entry, is a Cartesian product. Alpha 1 b beta 20 b is the third entry. Okay, and alpha 1 gamma 10b is the fourth entry. Then beta 2 a10a is the first entry, beta 2 b10a is the second entry, beta 2 this next entry, and r beta 2 y10b is the next entry. So this is a Cartesian product is denoted as a cross. It is denoted as a cross. And normal SQL query of this is what? Normal SQL query was select all attributes, select star from student 1 comma student 2 is a Cartesian product. The Cartesian product query in SQL. But in case of the relational algebra, this query is pi of a of r, pi of a of suppose some attributes. This is a Cartesian product. Means here use cross sign, not is multiplication, is a cross sign. Okay, this is in relational algebra query. So total number of record 3, 3 into 3, 9 is the result in here. So same here 2 into 3. Just suppose s into r, then result s into r result a10a a alpha 1, then a10a beta 2, beta 10a alpha 1, beta 10a alpha 2, beta 2, beta 10b alpha 1, beta 10b beta 2, gamma 10b alpha 1, gamma 10b beta 2. This is a Cartesian product. It's an operation in relational algebra. So here this is not a relational algebra. This is a tuple. ते आपण नाही पाहिलेलं अजून. So this is a relational algebra operation. Means की pi of a comma b, pi of a comma b query कशी असेल? Query of this pi of a comma b, and here pi of a comma b, and third attribute is what? sorry, CD. Here CD, C attribute and D attribute and E attribute. So this is a query of the relational algebra. Pi. Actual notation here, okay, pi. And here this is a query of the relational algebra. Hmm. Then last, rename operation is a row. It is denoted as a row, means change the name of the relation. Change the name of the relation. So here use a row operation. So allow us to name and therefore to refer to the result of the relational algebra expression. So this is a row operation, row of x e. Return the expression e under the name x. Okay, so it is denoted as a row, and here means relation name. So using this row operation, rename means actually relation name. Using this rename operation, division operation means divide. So a b is a one relation, means r relation, s is a second relation. So r divide division s. So 1 divided by 2. So here 1 divided by 2 here available here. Here 1 divided by 2 available here. This 1 by 2 here common. So here 1 by 2 here alpha. So here alpha is the result. Then 1 2 common, 1 2 1 2 here. Here not common 1 2, but actually 1 and 2. 1 for beta here. Here 1 for beta, 2 for beta. 1 2. So 1 for beta, 2 for beta. So here beta. So this is the result of the division operation in relational algebra. So normal questions in suppose relational algebra. So here discuss some questions only. Which operation is used to extract the specified column from a table? Listen carefully. Which operation is used to extract the specified column from a table in relational algebra? Project operation pi. And suppose records or tuples, then select operation. Suppose A, B, and C, D are two relation schemas. Let R1 and R2 be the corresponding relations instances. So beta is a foreign key that refer to C in R2 if data in R1 and R2 satisfy the referential integrity constraints. Which of the following is always? Pi means the projection. Pi b of R1, pi c of R2 is equal to phi. Pi c of R2 is equal to pi b of R1, phi. Pi b of R1 is equal to pi c of R2, third option. Pi b of R1 is equal to pi c of R2, phi. So option is A. Okay. So one example, this get example. So in this example, consider the following relational algebra query. Pi of employee, okay, employee ID, employee minus pi of employee ID, employee is a relation, pi means the projection, this is attribute name, and the above query evaluate the set of the employee for employee whose age is greater than that of. So all of his dependents is the answer of this query. So means ki today's lecture means ki discuss only 2 points of the GATE exam. Okay. Today's point is the ER model and relational model. ER model, relational algebra, entity diagram, then component, entity set, attributes, types of attributes, composite attributes, multi-value derived attribute, relationship set, unary, binary, ternary, quaternary, constants, one to many, many to one, many to many relationships, total participation, partial participation, key, super key, candidate key, primary key, then foreign key, extended data diagram features, specialization, generalization, aggregation, specialization concept, then types of specialization, example of the specialization, then generalization example, then attribute inheritance concept in extended AR feature, user defined, then coverage, total generalization or specialization, partial generalization or specialization, aggregation concept in ER diagram, then ER diagram with aggregation, then schema diagram, and then ER diagram of the bank system. Get exam questions for the ER model, discuss some questions, get exam questions, discuss here these questions of the get exam. Then relational model, discuss relational model example, attribute, domain, tuple, relation, degree, cardinality, relation key. Then advantage of the relational model, simple, scalable, disadvantages, then example of the relation, attribute types, relation schema in detail, keys, super key, candidate key, primary key, foreign key, discuss here. Then discuss important point is the relational algebra. Relational algebra discuss six operations, sigma, project, union, set difference, Cartesian product, rename, select used for select record purpose, for the specific attribute purpose, union for the union result purpose, set difference for the minus purpose, set difference, and similar operation in SQL is the minus, Cartesian product for cross notation, rename notation, example of the select operation, then project operation example, then union operation example, set difference operation example, discuss, then set intersection operation example, Cartesian product operation, rename operation, division operation. Okay, then some questions here, discuss only 2 to 3 questions because time खूप झाला त्याच्यामध्ये, right? And here these questions, okay, get exam questions. Okay, so actually in get exam in syllabus, so we cover this point, model, relational model, and relational algebra. These points cover in today's lecture. Means at any time, any doubt for the DBMS get lecture or DBMS any point for the get exam purpose, so contact me, no problem. Okay, so this subject is a very easy, and at the time of the student phase, I get out of mark in DBMS. In 2009, I means the first time attempt for the GATE exam and get out of marks for the database subject in, and my score is this time कि 92.94 percentile score is a very good score in 2009. Today means ki suppose maximum is good score is a means ki 99 percentile, and this score is good score. For qualification purpose in GATE exam is very easy, because one simple example ki last year means one of the student is Anush Pulari, and means anytime contact me ki take the means ki Anush means ki details for the every lecture of the my specific GATE lectures. So this student attend means की all points of the my gate lectures. ओके, मी असं नाही म्हणत की सपोज माझं ऐकलं म्हणून त्याचा स्कोर आला, राईट, पण ॲक्च्युअली दिस स्टुडंट इज अ व्हेरी सिन्सियर स्टुडंट, अँड इज क्रॅक, नॉट ओनली क्रॅक गेट एक्झाम, सो ऑल इंडिया रँक इज 64 फॉर द सी एस ब्रँच. ओके, मग त्याला एवढं नॉलेज असून सुद्धा तो सगळं करतो, केलं त्याने अटेंड. ओके, एखादा म्हणलं असतं मला माहिती आहे काही गरज नाही आहे, पण ती स्टुडंट इज अ ब्रिलियंट स्टुडंट. मी असं नाही म्हणत की तोच आहे, तुम्ही सगळे करू शकता. अँड मोस्ट ऑफ द प्रॉब्लेम ऑफ द गेट रिझल्ट इज की सपोज की इझी आहे असं सगळं तुमच्या माइंडमध्ये असतं, राईट, पण ॲट द टाइम ऑफ द एक्झाम मीन्स की आउट ऑफ सपोज इन एनी ब्रँच ऑर कम्प्युटर आय टी मॅक्सिमम 2 to 3 स्टुडंट्स क्वालिफाईड इन गेट एक्झाम, एवढं सोपं असताना सुद्धा तर सिरियसली घेत नाही आहेत, त्याच्यामुळे तो होतं, राईट. सो तुम्ही स्टडी करा, इट इज अ व्हेरी इझी की गेट क्वालिफिकेशन क्वालिफाईड इज व्हेरी इझी. सो इन एनी डाऊट एनी टाईम और एनी क्वेश्चन इन गेट एक्झाम तो कॉन्टॅक्ट एनी टाईम मी, की नो प्रॉब्लेम, तुम्हाला कधीही मी त्याच्याबद्दल सांगेल, बिकॉज की मला तो एक्सपिरियन्स आहे, बिकॉज इन फर्स्ट अटेम्प्ट आय गेट मीन्स गुड स्कोर इन गेट एक्झाम. ओके, so one simple request here means ki put up here means ki uh, fill means ki get feedback form, okay, for requirement of the college data purpose. So please means ki fill this Google form, feedback form of this lecture. Okay, and next lecture means ki next Saturday, so I cover means ki also means ki some good points of the DBMS with some questions, get exam questions and all in details in next get lecture. So please attend next lecture in next Saturday. Okay, so please fill this Google form, and then no problem, त्याच्यानंतर लेफ्ट झालं तरी चालेल, or means any question then ask me, no problem, any question ask me for regarding means की get exam or these points, any questions. If no questions and here means की type your name in chat box, no problem, so मला कळेल की कोणी कोणी lecture attend केलं. So type your name in chat box and fill this Google form, please. Any question or any doubt, no problem. Any doubt then ask, no problem. ओके देन इन डाऊट नसेल तर लेफ्ट केलं तरी चालेल. अँड मीन्स एनी टाईम तुम्हाला काही डाऊट असेल तर मला विचारा, नो प्रॉब्लेम. ओके. ओके, सो लेफ्ट झालं तरी चालेल, नो प्रॉब्लेम.